Hi, my name is Leanne, and we are going to look at three methods to reduce extraneous cognitive load. As instructors, you have a lot of experience preparing slides and presenting and explaining content to your learners. Cognitive load theory and the cognitive theory of multimedia learning provides us with some research-based premises that may allow us to decrease the cognitive load for our learners by minimizing extraneous cognitive load caused by our presentation style. After we discuss the three methods, there will be a short presentation on preparing for an interview. Try to determine how the slides exemplify good instructional design according to the principles of redundancy, coherence, and signaling, and how they decrease extraneous cognitive load. Cognitive load describes the total amount of mental energy that is required to process new information, with the rate-limiting step being working memory. Poss and Sweller in 2014 compared knowledge that must be acquired to genetic knowledge obtained through evolution. They divide knowledge into primary and secondary information. Biologically primary knowledge is knowledge that we've been genetically programmed to acquire. It is usually easy to obtain, requires little to no effort, and can be done subconsciously. Biologically secondary information usually requires the use of primary knowledge. It is more difficult to obtain, and you need to expend energy to obtain it. As an example, listening and learning your native language is primary, and reading to learn is secondary knowledge. According to Poss and Sweller, biologically primary information is stored in independent modules in long-term memory, while secondary knowledge is organized into schemata. The more variations of a given related theme a person is able to process and store, the more fluent they'll become in a given subject area or skill. There are three loads that make up the sources of cognitive load. The first is intrinsic cognitive load. The intrinsic cognitive load is the demand on working memory required to work with the secondary knowledge. It is in direct relation to the complexity of the material itself and is due to the level of activity between the knowledge components. The level of energy required is determined by the content and cannot be changed, only managed. Extraneous cognitive load, the one we're talking about today, is the effort that is required for working memory to process the information based on the way it's presented. Poor instructional design will increase the number of interacting elements and therefore increase cognitive load. Germane cognitive load is the energy that's left to process the secondary information or intrinsic load into schemata that will be stored in long-term memory. The goal is to decrease extraneous cognitive load and maximize germane cognitive load. The assumptions of the cognitive theory of multimedia learning by Mayer. Humans have the ability to process both visually, spatially represented material and auditorially, verbally represented material in separate channels. If there's sufficient energy involved, information entering one channel can be converted to a representation in another channel. Each of these two channels has a limit to the amount of information that it can process in a given period of time. A memory span test is one way to test an individual learner's capacity. A key function of the executive control part of the cerebral cortex is to allocate resources or determine processing priorities. Learning is an active process that requires the ability to select relevant information, organize the information into mental models, and then integrate it with information in long-term memory to form schemata. According to Mayer, multimedia design must not only have a coherent structure, but it also must guide the learner in how best to build a knowledge structure or mental model. The first step is guiding the learner while they select relevant words and images. Then they must help the learner organize the material by allowing them to see relationships between the components and to recognize patterns. Finally, the designer must help them build connections between new knowledge and already learned knowledge stored in long-term memory. First, the redundancy principle. The redundancy principle states that people learn more deeply when they have graphics and narration rather than graphics, narration, and on-screen text. Requiring the learner to try to coordinate redundant information with essential information increases memory load and interferes with learning, according to Poss and Sweller. The cognitive theory of multimedia learning posits that there are two channels, each with limiting processing power to bring information into working memory. On-screen text and images or diagrams would both use the visual spatial channel. Spoken narration would use the auditory verbal channel. Using spoken text and on-screen images or diagrams would make use of both channels without overloading either one. The redundancy effect was not demonstrated with very short segments of text were used. Redundancy may be beneficial for non-native speakers, learners with hearing disabilities, when there's no graphics or when technical terms are used, according to Kluge and Sweller. An important caveat of the redundancy principle is that it does not apply when both spoken and written text are both needed for understanding. Another example of redundancy presented by Kluge and Sweller is redundancy of actual equipment. Having an instruction manual to read along with the actual computer may be redundant. Learners may learn more deeply with just the instruction manual. A possible explanation is that when an instructional manual is used along with the equipment, there may be a feeling that any needed instructions could be looked up on a just-in-time basis, or the instruction manual instead of actually learning the content. The coherence principle states that people learn more deeply from multimedia when extraneous material is excluded. It is tempting to include stories, videos, and random facts that would be interesting to the learner, but not necessary to understand the content. This extraneous information increases extraneous cognitive load, decreases available energy for essential processing, and can be confusing to the learner, according to Mayer and Fiorella in 2014. The detrimental effects of adding extraneous information is even more significant in learners with low working memory capacity. The cognitive load imposed by the task, the interest level of the task, or when the content is presented using a system-based method instead of a learner-based method. And finally, the signaling principle states that people learn more deeply when cues are added that highlight the organization of the essential material or to help them select the most relevant information, according to Van Gogh in 2014. These cues can be done textually by adding underlining or bolding, by using imagery such as arrows or highlights, or auditorily by emphasizing certain words. In the theory of multimedia learning, there are 3 steps: selecting images and text, organizing images and text, and then integrating the information to build connections or schema. Signaling helps with selecting images and text. This selection process is necessary for the information to be available to working memory. Research reviewed by Mayer and Fiorella showed that novice learners tended to attend first to the most salient feature of the content. In addition, they showed that learners performed better on transfer tests after reading a summary of the required content instead of the full-length version. Effective signaling makes more processing power available to facilitate the germane cognitive load. Mayer and Fiorella also demonstrated that picture cueing had a significant effect on retention, but not on information transfer. Signaling seems to have a more significant effect on low-skill learners than on high-skill learners. Some research reviewed by Mayer and Fiorella in 2014 showed that some learners did not perform better with signaling, even though eye tracking showed that they responded to it, whereas learners with more knowledge of the task took faster and proportionally longer at relevant aspects of the task, according to Van Gogh in 2014. Signaling has been shown to be most effective when used with learners who have less background knowledge, when it is used sparingly, and when the display is complex. There are 3 main tasks you should have preparing for an interview: updating your CV or curriculum vitae, preparing your wardrobe, and preparing answers to common questions. First, prepare your CV. This is a sample CV on Career Essentials. Make sure that you're careful that your headings are prominent and clearly defined. Start with education first and put your education in reverse chronologic order. Make sure that you choose your next heading carefully, since it will also be on the front page of your CV. Make sure it is an activity that contributes to the brand you want to market to the residency program director. Prepare your wardrobe ahead of time. Make sure you choose a conservative outfit. Make sure your suit is well tailored, clean, and wrinkle-free. Pack extra shoes, belts, shirts in case you have any mishaps with your wardrobe. Men, dark, well-fitting suits and solid-colored shirts. You can show some of your personality with your tie and your socks, but be careful not to be too flamboyant. Women, a skirt or pantsuit or a conservative dress. Wear comfortable shoes since you may be walking a lot on interview day. Make sure that your neckline is conservative. Finally, prepare questions for your interviewer, as well as questions to common interview questions. You can find questions on the Career Essentials pilot page. Make sure that you're prepared for one-on-one or panel interviews, as well as both standard and behavioral questions. If you want to brush up on your interview skills, consider a mock interview. Notice in this interview, it is a panel interview where the interviewers are taking turns asking questions. Notice that the applicant has good eye contact and is facing the interviewers. Well, I hope this was helpful in going over 3 main principles for reducing extraneous cognitive load. Thank you for joining me, and if you have any questions, please feel free to email me.